Okay, in this video, we're going to tackle question number 5, which is a short answer free response, and it has to do with kinetics. I've revised this a little bit just to get all the graphs on here, but one of the things you may want to do for the exam in 2020, because it is open notes, is put down some information that isn't necessarily on your formula sheet, and one of those is just being able to look at graphs and knowing that if it's graphed with concentration versus natural log or your reciprocal, concentration would be 0 order, this would be first order, this would be second order. So I would put the units of measurement for your K value as well. So let's take a look at this problem. It has 3 parts to it. I have all 3 parts initially. We're going to break them down one at a time. But in part A, they are asking for the initial pressure of the reactant. Part B, they want to know the rate law based upon the graphs that you saw. And in the final one, they want you to calculate the K value. So let's start with part A. In part A, they want you to calculate the initial pressure. I pulled out this particular graph because on the y-axis it does have concentration. They're asking for initial pressure, so I am going to use my gas law. So that's the formula that I'm going to use to solve this. I know my temperature, I know my R value, I don't know volume and moles, but I do have concentration over here, and concentration is moles per liter, per 1 liter. And if I look initially is at time 0, I know that the concentration is 0.020 moles per liter. Okay, so if that's moles per liter, I'm going to assume a 1 liter container, which means that my moles would just be 0.02. So rearranging this to find my pressure, I get this. And now I'm just going to plug in those values. I've got 0.020 moles. My R value is 0.08206, and I'm going to leave, just for sake of time, the units off of that. My temperature, remember it's always got to be in Kelvin because your R value is in Kelvin, and it's 1 liter. When you solve for that, you should get 1.0 atm. Okay. So that's for problem A. For problem B, we're going to go back to what I said earlier. You're going to look at the graphs. You're going to try to find that straight line. If it's concentration, it gives you the straight line. Overall, it's a 0 order. If it is the natural log, that's going to be first order. Reciprocal is going to be second order. Be careful with this. A lot of students will go 1, 2, 3. It's 0, 1, 2. So here is concentration. This is my natural log, and this is my reciprocal. I don't have a straight slope right here or here. This one gives me sort of the straightest line for both trials. So based upon the data that I see in here, and they're saying just use the data plotted in the graphs. They're not asking you to justify your answer. You can say, given that the graph of the reciprocal versus time gives me a straight line, I can conclude that it is second order. Okay? And our last part of this problem, they're asking you to find the initial rate of the reaction. So if I write my rate law, it is second order. There is only one reactant, so it's going to be second order. in respects to that reactant. There's my rate law. I'm trying to find my K value, so I'm going to rearrange that. And I would get this. Be careful in kinetics when you are solving for K. You need to have the correct units of measurement. So as you're solving this problem, I would recommend that you solve it not just in numbers, but units as well, or that might be something else that you write down to help you in the 2020 exam. Okay, they did give me my initial rate, so I'm going to put that up here. It is 0.0010, and that is moles per liters times seconds. Okay, from that concentration graph, we knew the initial concentration. We used that to solve our other problem. Our initial concentration was 0.020, and that is moles per liter, and I'm going to square that. And so when you solve for this problem, again, remember, solve it for the units too. You should get 2.5. Since this is squared, that's going to cross out. That's going to cross out. And this is going to flip. So you would have liters per mole times seconds. You could also solve this. This is using our differential. This is using differential rate law. If you go on the scoring guidelines, there's another method to using the integrated form, which we really didn't get into too much in class, but you can use that format to solve this problem. That's it for problem 5. I will post another video for problem 6 shortly.